Hi guys, welcome to chapter 16. So we're going to talk about iterators in this chapter, and iterators may take a little bit of time for you to get your head around, to be honest. We sort of referred to them, we talked to them a little bit in the last chapter, and I gave you sort of a vague definition of what they are. We're going to talk about very specifically what they are in this chapter. And you're going to have to kind of get your head around it because it's a little odd, okay, at first. Once you get the hang of it, it's easy, but you're going to have to think about this. You're going to have to use it a little bit. So the scope of this chapter, we're going to talk about the purpose of an iterator. We're going to talk about the iterator and the iterable interfaces. We're going to talk about the concept of fail-fast collections, using iterators to solve problems, and then iterator implementations. So an iterator is basically a way that you can go through the elements of a collection. So if you think about how you do that under different implementations, like an array list versus a linked list, it'd be very different, right? The one, you're just incrementing the index. The other one, you're like going through the next pointers to find the next one. So an iterator is sort of like it's a more generalized object that lets you do this in a more general way. So it works across all types of collections, and it works in the same way across all types of collections. So it is a more generic way to loop through the elements of a collection that abstracts away the underlying mechanisms of doing the actual traversing or whatever. So iterators work with a collection, but it's a separate object. So the iterator, again, it simplifies the classic step. Simplifies, I guess that's probably true, the classic step of processing elements in a collection. Again, you got to get your head around this. So there's two key interfaces in the Java API related to iterators. So the first is the iterator interface, and that's actually defines the iterator. And then there's the iterable, I say this right, the iterable interface, which defines a collection and provides an interface. So if we saw before that the things were listed as iterable, so if you're going to provide an iterator, if you're writing a collection and it's going to provide an iterator, that it needs to be an iterable, it needs to implement the iterable interface, which is super simple. So a collection that's iterable just means that it's going to provide an iterator when it's requested. So we'll look at these interfaces. They're pretty simple. So we have the iterator interface, which has three methods. One is hasNext, and that's a Boolean, returns if there is another element in the array. There's also the next function, which returns the next element in the iteration. And so if you repeat, so let's say you start with your iterator and you say, hey, collection, give me an iterator. And it gives you an iterator, right? And you say, my object equals, iterator dot next. Then what it's going to give you, what's going to be your my object reference is now going to point to the first element in the collection, right? And then every time you call next, it's going to give you the next element of the collection. Does that make sense? So that's why we need the hasNext. You'll see in the loops how it works exactly. So finally, we have the remove function, which removes the last element returned by the iteration from the underlying collection. So that's the iterator interface. It's very simple. We have the iterable interface, which all it does is return an iterator, right? And it's a generic type, so it's going to return an iterator, and that's all it does. You're just basically promising, if you ask me for an iterator, I'll give you one, and there's the function definition for it, the class method for it. So let's assume that my list is an array list of book objects. So we have an array list of book objects. So let's look at this little piece of code. We can say iterator book itr equals mylist.iterator, and what that's going to do is that's going to get the iterator for my list. So we're going to say itr.hasNext, and we're going to do that because we're actually going to check to see if there is a next before we get the next. Otherwise, we're going to get an exception thrown, right? Because there's not going to be a next. We're going to ask for the next, and there actually is nothing for it to return. So in your loop, you're going to say, while it has a next, we're going to call system.out.println iterator.next. So iterator.next is going to return the element in the next element of the list, starting from the first element, or zeroth if you're looking at it, depending on how you like to do your things, right? It's going to be array index 0 because this is an array list. And then the next time so let's say we've got 3 elements in our list, all right? Our array list. So we're going to say while itr.hasNext, and that's going to be true. We're going to say system.printout itr.next. That's going to print out index 0, right? And it's going to bump it up. So the next one after index 0, the next time you call next, it's going to give you index 1, right? So there is a next in that case. We jump up. We say while iter has next. That's going to be true because there is another one in there. We're going to come down. We're going to print that. System.next is going to return index 1 in our array, right? Now there's one more in there. So we're going to jump back up while iter has next. That's going to be true. We're going to go down. We're going to call iter.next. It's going to return 3, or sorry, element 2, index 2, the third element, but index 2 in our array list. Now there's nothing else left in there. There are only 3 elements in there, right? So it's going to come back up, call iter.hasNext, and that's going to be false because there's nothing else in there. So that's in a nutshell how that works. It just lets us loop over the things using these 2 functions. So the first line obtains the iterator, and then the loop uses these 2 things to access and print each book is basically what happens in this code. All right. So for each loop can be used for the same goal. So we can use a for loop, and the syntax for this, is a little odd, right? If you've taken Python, you've seen this, and basically in Python you'd be looping over a list, which is a base type in Python, and it's built to do this. This is actually I think it's a fairly recent addition to Java. I remember when I first learned Java, I don't remember them having this syntax. I think this has been added. They're always kind of adding things to Java, but it's not bad. So what it does is we declare this book, which is the thing that we're going to. So this is syntactic sugar. So basically what this is going to do, it's going to unwrap this into the iterator code that we saw in the past. This is exactly equivalent to the iterator code from the previous slide. It's exactly the same as this. We're just going to wrap it in something that's going to make it look pretty. So book is going to be the variable that's going to hold the value that's returned back from .next for the iterator. And then we're going to call system.println.book. And then essentially what's going to happen to this thing is for everything that's in the element in the collection MyList, the value book, the object book, the reference book is going to point to the first one, the second one, the third one, the fourth one, the fifth one, sequentially from 0 to, n-1 or whatever it is. So behind the scenes, the for loop is going to use an iterator. It's basically doing this, exactly this, but it's just written in a pretty way. So we can say we declare the thing that's going to hold our value, the value of the list as we loop over the list, and then we're going to just print out that value. So if you took Python, if you've ever used any Python, you've seen this before. Python for loops work just like this. In fact, they only work like this. But this is another way that you can write loops in Java. So the for loop we can use this for each loop on any object that's iterable. So anytime anything that's iterable, we can use this on, okay? And the thing that goes over here is always the type of the element that we're storing in the list. And a colon, and then the thing that we're going to loop over, the collection that we plan to loop over. Okay? And we can actually declare any object iterable. It doesn't have to just be a list. We could do all kinds of crazy stuff. As long as you implement the iterable interface, which returns an iterator, and you implement an iterator, then the syntax will work. All right? And you can do just bizarre things with it. All right. So you may want to use an iterator explicitly if you don't want to process all the elements. For example, you're searching for a particular element. You may also use an explicit iterator if you want to call the remove method. So if you go back and you look at this, we can't remove things because we never actually see the iterator. It's hidden from us in the syntax. So the for loop doesn't give access to that, so we can't call it. A lot of times, though, we're going to want to loop over things and print things out. So this is actually not a bad syntax for a lot of cases. It doesn't have a lot of flexibility in what you can do. You can't skip over or do every other one. Again, if you're a Python programmer, you know that you can use this to do all kinds of nice stuff that it's not allowed here. All right, so you shouldn't assume that the iterator is going to give the elements to you in any particular order unless the documentation explicitly says you can. So there's no guarantee that it's going to go like it's the first thing or the last thing that you insert into the collection is there's no guarantee that that it's going to be the first or the right. There's no guarantee on order when you're using an iterator. Seems odd, but you got to remember that the underlying collection is free to. So, for example, you can implement like a list. You could actually implement one with a tree, where we'll see trees later, but you can actually implement them in different ways, depending on what you plan to do with it. So, if you implement it as a tree and you do a search, it's super fast to find in a tree. Whereas with a list, so if let's say you're going to be searching your list a lot, but you want to use a list structure, you could implement the underlying one with a tree. Searches would be order log in, whereas with a linked list implementation, they would be order in, right? So the iterator itself is related usually to the underlying structure of the collection, which is not guaranteed when you're using a lot of times. So don't. Unless the documentation says it's going to give you to a particular order, then assume it's not. So remember that the iterator is accessing the elements stored in the collection. So you should not change. You should not change the collection while you're iterating over it. Okay? Because you can accidentally invalidate the iterator that you're working with. Okay? Does that make sense? Like, let's say you're going through a linked list. You've got an iterator. You call .hasNext. It says sure, but then you go inside and you delete everything from there to the end. Like, when you try to use the iterator, it's going to crash because the iterator was invalidated by the fact that you manipulated the collection. So you should not change the collection while you're using the iterator. For that reason, because you can destroy the thing that you're iterating over. It's dangerous. It's not safe. So most iterators in the Java API are what we call fail fast. So you saw that mod count that we're looking at before, where it was keeping track of had it been modified or not. That was for the iterator implementation. So if you implement an iterator if you have an iterator implementation, when you create the iterator, it keeps track of the mod count. Let's say it's at 44. If you go in and you make a modification to the class, then the iterator and mod count and the collection mod count will not agree. And if that happens, there will be an exception thrown. All right, because you're not supposed to modify the collection while you are iterating. Now, that's only enforced by the Java API. That doesn't mean that happens magically. There's a check in there, right? There's a check in there to see if that mod count is the same as it was when you created the iterator. And if it's not, then it's gonna crash. So if you implement your own iterable container and you don't check that, then that's not something that's guaranteed. It's not guaranteed to fail fast. The fail fast is because of that mod count that we're looking at in the last chapter videos, right? It's keeping track of, did you modify it after you created the iterator? All right. So that's the end of that lecture. We're going to come back and look at some more on iterators in the next section. Thanks, guys.